Hello, my name is Paul, and I appreciate you hitting play here on this video. So, just to kind of set this up, I was recently in Lake Tahoe, or on Lake Tahoe, around Lake Tahoe, and I was there on a personal and business trip. And I decided that I might just take a couple of hours and head out, take my Nikon P900, cool pics. Forecast looked pretty good. As you can see, this was a video that I shot. Actually, this was taken with my iPhone, but as you can see, it was a very nice day. And a video that I shot while I was heading from our cabin down the west shore, heading south around the lake. So what I thought I'd do was do a little exploring and find an object that would be easy enough to find, I guess, basically something that would be high enough to see from a great distance, and then head around the other side of the lake and see if I could see it over the water, assuming that water is flat. Or excuse me, there would be very little obstruction in looking over water, and measure to see if there was any convexity, I guess, of the water. So that's what I did. And so what this video is my documentation of the experiment, and hopefully you'll find it interesting. I'm sure there'll be some folks that will try to discredit it, try to point out some things that I missed, that my math is wrong, or I didn't take this into consideration, and that's how we all learn. So let's go ahead and jump in, and I will kind of show you what I saw, what I observed, and kind of how this thing unfolded, and then we'll get to the end, and I'll kind of share with you the conclusions that I drew from the time on the water and around the lake, and we'll see where we end up. Okay, so the first picture here is just in case you don't know much about Lake Tahoe. Maybe you've heard about it. Lake Tahoe is a very high in elevation lake on the border of California and Nevada, and in fact, I think it's the first or second deepest lake in the country. I'm trying to remember. I was reading a little bit about it. What I do remember reading was that it is approximately 22 miles long in its or from its furthest point, north to south. And here's a better picture of it. And I think 12 miles across at its highest point, or at its widest point. So this was the lake that we were staying on, and kind of served as a great spot to do an experiment like this. Okay, so this picture was taken actually the day before. I was snowboarding snowboarding at a resort called Squaw Valley. So at the top of the lift, you can see the lifts there on the left. At the very top, you could see the lake and how high it is in elevation, because we were probably about 8,000, 9,000 feet there, and the lake is about 6,200 feet or so above sea level. So it's a very, very high and cool and clear lake. So great tourist destination. As you can see, we had good weather. This is the day before, and the day that I was on the water was even better. Okay, so this picture is something I found online. So I didn't take this picture, didn't have a drone, didn't have a helicopter, but what I found was in my research that in the southeast corner of the lake was a town called South Lake Tahoe, and right on this California-Nevada border, there was a casino, two buildings, very prominent, as you can see the highest structure in and around the lake. So this served as a perfect object for me to observe from a long distance away, in seeing what I could see. So the building on the right is Harvey's. It's called Harvey's Casino, and I believe it's 19 stories tall, and it's the closest to the lake. And then Harrah's is the building not directly behind it, but kind of to the left and behind it, depending on where you're from. or where your vantage point is. So, but I wanted to kind of show you this kind of close up initially of the two buildings, because when I go over and I show you what I saw from across the lake, it'll kind of make sense. You can kind of get, I wanted you guys to focus on this so you can see what it looks like. And I really want you to pay attention to, on Harvey's, the building on the right, that very prominent L shape at the very top right. You can see that there's this, it looks like a couple of floors or above the main structure there. And that L shape, or that dip in the building, becomes very prominent later in the video. So I want to make sure that you guys saw that, and I pointed it out. This picture is another picture I found online taken from Harvey's Casino. So if you're in one of the rooms and you're looking out, you can see kind of how far it is away from the lake, first of all, but that there's trees obscuring, the first couple of floors at least, and then you can see the lake. So I wanted to kind of see the vantage point, and then looking across the lake to the other side, that's obviously where I then make my observations. Here's a map showing South Lake Tahoe, and on the very kind of southeast corner of the lake, you can see where the state line is there between Nevada and California. And so Harvey's is right on the Nevada side of the border, right there in the town. So this picture is a picture that I took, and when I made it into South Lake Tahoe, I went to one of the beaches there so I could kind of see how far away the Harvey's Casino is from the shore. And you can see over there between the two trees there, you can see the building, you can see that, again, that prominent L shape, as I call it, facade of the building, which again I'll point out later. And so the next few pictures here, I'm just getting a little bit closer so you can see, using my zoom, what the building looked like from the same side of the shore. And then as I was heading out, I took a picture of the Harris building. So this is another picture I took on my way back away from the beach, and then going to start and heading north. So I kind of took some pictures of the buildings, kind of got an understanding of what I was going to be looking for when I got to the other side of the lake, not knowing how far away these were going to be yet, but getting an idea of what I'd be looking for. Okay, so from there, I started heading north. So I was driving really all the way around the lake. So I started up kind of on the western shore, drove down to the southeast shore. That's where the two casinos are, the two buildings are, and then I started heading north along the eastern shore. And as you can see, it was an absolutely gorgeous day. There was not really a cloud in the sky. Temperature was in the low 40s. But it was generally just a really, really great day to be out making some observations and kind of doing some experimentation on the convexity of Lake Tahoe, if it exists. And that's what I was attempting to find out, if water was going to be curving and obscuring some or all of those buildings from my line of sight. All right, so the picture in front of you now is showing where I ended up setting up my camera for the shot. So as you can see, I drove all the way around the north shore and to the northwest corner of the lake. And the reason I did that is I really wanted to make sure that I was far enough west to be able to see the southeast corner. I didn't want any obstructions to my view across the lake, so I didn't shoot the length of the lake. It really ended up being more of a diagonal shot from the northwest corner to the southeast corner, and you can see the blue dot there is where I ended up settling in to make the shot. And then on the bottom right, you can see is where South Lake Tahoe is, and the state line, which is obviously where the casinos are, where the two buildings are of the casino. So just a shot, again, a screenshot from my iPhone showing I was using Google Maps to show where I was. The beach was called Commons Beach. And here's a shot of what that looked like from my vantage point. So obviously full of snow. This is the 1st of March. So, and they've had a good year up there in Tahoe. The amount of snow, a lot of good skiing and snowboarding. So there was a lot of snow everywhere. And then this shot here is looking little bit down the shore of the of Commons Beach, and you can see, if you look to the right side of the photo there, you can see a little bit of sand showing through the snow, and that's where I ended up settling in to get, I wanted to be obviously as close to the water and as low as comfortably possible to make the shot, so that I didn't have to subtract a lot of height or elevation height from my camera. All right, so this is a video I took zooming in. So I had set up my tripod there right on the beach, and had zoomed in on the water to just kind of show you the level of distortion that I was getting on the water as I was zooming in. So you could see how much obscurity there was shooting over the water. I think it had a lot to do with the humidity, the air temperature, and the sun being very bright. There was a lot of factors that were kind of working, I think, potentially against me and seeing a long distance. And as you can see, and trying to focus in, you can see directly above the water how much distortion there was above the water. All right, so this shot then is once I had been able to locate the two buildings. So I pointed the camera in the right direction and began to zoom in, and I found those two buildings right between a yellow buoy and a white spherical buoy, and there's Harrah's on the left and Harvey's on the right. And the reason I could tell, and what caught my eye when I was scanning the coastline there, was that prominent L-shaped facade at the top, as you can clearly see. Here I'm back to taking video and seeing what kind of a close-up I could get from this distance, trying to use manual focus to get in there and really be able to see. But what I wanted to point out here is the level of reflection that you can see. If you look at the bottom of the casino there, the building, you can see that at the very bottom, you can see a perfect reflection of that facade, that L shape at the top. So we've got a mirror image, and that's typically what you're going to see over long distances on water is the sun creating or the light creating a reflection. So it's a mirror image. So the line or the water level is much higher than what you're observing there. And so I've got a couple of pictures coming up here to kind of illustrate that. This is a shot I took from a different part of the lake, and as I zoom in here, you could see this level of reflection of the rocks here. And so what I do is I draw a line here across there so you can see where the water line is, and then it looks like the rocks are kind of sticking out there and floating actually. And that's typically what you would see also with like a boat. And here was another picture of a boat I took that was also on the lake. As you zoomed in, it looks like it's floating in air. Well, no, it's just the water level is way up here, and that's where the water line is. As you can see, it's much lower. So here's just a shot of me. I was happy that I had seen the buildings across the lake. And so what I needed to do next was just really determine how much of the building could I see, because I've got reflection to deal with here, of course, and I hadn't done the math yet. I didn't even know what distance I was at yet, so I couldn't do the math, but I wanted to be able to kind of figure out how much of the building was I able to see, considering the level of reflection that I was getting. All right, took a couple of more screenshots from my iPhone, just so you could see the temperature. It was around 1:30, 2 o'clock in the afternoon, somewhere around there, and the humidity was 39%, barometric pressure, etc. All right, so this is another stock photo I found online of Harvey's Casino. You can see again the prominent L facade at the top there. So what I needed to do was I needed to determine what the approximate height of the building was, or at least what the approximate height would be of that top part, so I could start to kind of gauge how much of the building I was able to see. So what I did is I jumped in my paint program and created some boxes all of the same size and stacked them up. And I made the top box be exactly the size of that part that jets out or jets up from the top, and to determine what percentage that is of the entire building, because I could see that from obviously very far away. So I determined that it was just a little bit more than 6 of those boxes. So I measured the top box, and then I made the ones below it obviously the same size. And it's about 6, 6.1, 6.2, if you will, of those boxes. All right. So then what I did is I went back to the photo that I got from across the lake, and I did basically the same thing. So I drew a line across the middle, and I think I kind of sold myself short here because the line is not, it looks like it's maybe a little bit higher than it should be. I should be splitting those two, top half and bottom half. I should be splitting those down the middle. But I think I did a better job on the building on the right, which was the main thing. As you can see on the left side, the line looks a little bit higher than it should be. So anyway, what I'm attempting to draw there is the actual level of the water, and you can see the reflection below it. In fact, you could see both buildings in their entirety in the reflection, because you can see the sky, if you will, above the building on the right and the left in the reflection. But if I make a box of that top part of the building, the little L-shaped part, and then I use that consistently down, I was able to put 3 boxes before I would hit the water level. So that told me, again, approximately 6 boxes would make the height of the building. So roughly, yes, I was able to see, at a minimum, half of the top half of Harvey's Casino. I don't think there's any doubt of that. Probably might have been able to see a little bit more if the reflection wasn't as high, or the reflection wasn't as prominent. But I could see at least half of the building there. So now it was time to kind of see how tall the buildings were and how far away I was, and we can start doing some comparisons. And so this is a graphic of showing from Google Earth. I put in the longitude and latitude of my position and the building's position, and I needed to measure the distance. So according to Google Earth, I put those coordinates in, and the total distance, kind of small to see there on the very bottom middle, but it says 17.94 miles. So from my camera to the front of that Harvey's Casino was just a little bit under 18 miles. So that's obviously going to be very key when I go to calculate the curvature of the Earth. All right, let's do some math here. My camera elevation at Commons Beach was 6,222 feet. Harvey's Casino is 231.75 feet tall, according to Emporis.com, a website that has statistics on buildings. South Lake Tahoe is at an elevation of 6,225 feet, again, according to the web. So if we add those together, a total elevation of the casino of 6,456.75 feet. That's the object height of what I was looking to observe. So if we take the total elevation of the casino and subtract the elevation at my line of sight, you get a net rise of 234.75 feet. So that's what I'll be looking for across the lake. So if we take half of the height of the casino, we get 115.875 feet. And we know that we can see at least half of the casino from that picture that I took, that you saw earlier. I'll throw it up again here now so you can see that. At least half, maybe a little bit more I probably could have seen. Or that I probably did see. So now we need to crunch the numbers and see how my observations compare to some spherical geometry. This is where it gets interesting. Remember that I calculated the distance between myself and the casino using latitude and longitude for the 2 points in Google Earth, and it came to 17.94 miles. Here's that image again, and my line of sight across the lake, kind of a diagonal. Now I assume you know how to calculate the Earth's curvature, but if you don't, Here's how it works. Go on Google and search for this image here. Use some words like curvature and Pythagorean theorem, and you'll learn how to calculate that. So based on a circumference, an Earth circumference of 24,901 miles and a radius of 3,959 miles, the surface of the Earth, best measured over something flat like water, because water always finds and maintains its level, it drops 8 inches per mile. Now, if you just did that on a per mile basis, that would be a slope. So you have to square the miles. That's where the spherical geometry comes in. So you take the number of miles, 17.94, and you times it by itself, and then you multiply that by 8 inches, and you get 2,574.7488 inches divided by 12, and you get 214.56 feet. Now that number is very significant because that is the drop of the Earth that I should observe, or I guess should not be able to observe, at a distance of 17.94 miles. That's the amount of feet at that distance that I should not be able to see. It's below my line of sight, below the curvature of the Earth. So with the height of the casino rising 234.75 feet above my line of sight, I should only be able to see 20.28 feet of the building. However, as I've already demonstrated here, I was able to see more of that. I was able to see at least half the building, maybe even a little bit more, 115.875 feet. So further, I'd point out that the level of reflection in the water was very high that day because of the bright and sunny conditions. On an overcast day, I would expect to see even more of the casino at that distance because the level of reflection would be less. So I'm curious. I'm wondering how much of the building was hiding behind the reflection there. On a different day, I might have been able to see even more. Still, even in those conditions, which was a very nice day, I still observed there was approximately 95.6 feet of missing curvature. Guys, that's the height of a 9-story building that I shouldn't be able to see. So, conclusion time. Either the Earth is much larger than we've been taught, because I can see more than 20 feet, or Lake Tahoe is pretty flat. Water doesn't seem to convex. Water doesn't seem to be conforming to the exterior of a sphere here. As we tell everybody, do your own research, get out there, get over some water, see how far you can see, do the math, and let's see what happens. Thanks for watching, guys. I appreciate it.